We are solving system word problems with current. So we're going to talk about how the current works with us and how the current works against us. So first, obviously, I want to go over the top part. So that's the box that we're going to fill in for every single word problem. And these boxes, obviously you know, written a different way, rate times time equals distance. Okay, we're used to distance equals rate times time, but it's totally fine to just write it the opposite way. That's not bad at all. So basically what you're going to do is you're going to multiply the rate box times the time box, and it's going to equal what it equals. So make sure you put your x there for multiply, make sure you put your equal sign there for where it's going to equal. Okay, the rate is always going to be either I'm going with the current, x plus y, or I'm going against the current, x minus y. And the time is going to be however long it takes in hours. Time is always in hours. So let's practice that real quick. If I ride on a sailboat for 30 minutes, how do I translate that to hourly form? If I ride on a sailboat for half an hour, how do I write that in math, half an hour? 1/2, what's another way to write it? 0.5. Okay, everybody look at the clock. Oh my gosh, this is so perfect. If I sit on a canoe for 20 minutes, how much of the clock am I at? How much of the clock currently has been used up by this 20 minutes? 1/4? No. Less than a
1/5.
1/3. Okay. So, and I'll do the diagram. This is where the 4 is on the clock. This is where the 8 is on the clock. That's perfect thirds. Look at the clock again. The 20-minute sections, those are thirds. 20 minutes, 20 minutes, 20 minutes. So 20 minutes is a third of an hour. Third of an hour. 2/3 of an hour. 3/3 of an hour. Okay? What about 15 minutes on a clock? 15 minutes of a clock. 15 minutes is how much of an hour? 1/4. 1/4 in math is what number? I can't have you answering all of it. Do you guys know your time? 1/4 is how much of an hour? How do I write it as a decimal? 1/4 of $1 is how much money? 0.25. Okay, and lastly, obviously, this is obvious what comes next. 45 minutes is how much of the hour? This should be a question everyone knows. You will face this every day in life, dealing with time. 45 minutes, 3/4 of an hour, yep. And how do I write that as a decimal? 3/4 of $1, 3/4 of 100, 0.75. So the point of me doing all of this out is that sometimes our time is going to be, it's not 1. 1 is 1 hour, but sometimes I'm going to ride my bike for 15 minutes. That's only 0.25 that I would put for time. So time is always in hour format unless you go less or more. Half an hour, 0.5, half. So I would put 0.5 in for my time. All right, let's go to the first problem. A boat with a battery-powered outboard. Okay, this is what an outboard motor looks like on a boat. I don't know if you've seen it out of the water, but that's what it looks like out of the water. Propellers on the bottom, that's what revs it up and gives it speed and momentum. So now the motor is going to help the boat. It's not a canoe, it's not a rowboat, it's not man-powered by oars. So, needs half an hour to go 2 kilometers downstream. It takes 1 hour for the boat to go the same distance upstream. So we're going to go one at a time, downstream versus upstream. Okay? So, What do you guys think? What am I going to put for my time? How long does it take me to go downstream? Read the sentence. What does it say? Half an hour. How do I write that in math? Decimal's best. Please put 0.5. Remember, it's rate times time equals distance. It also tells me something else. To go 2 kilometers. Where do I put my 2? Distance, how far I went. That's my first equation. Let me write it out. X plus y times 0.5 equals 2. So what's going to end up happening is you're going to have to distribute like that. Okay, let's do the upstream. It takes 1 hour for the boat to go the same distance. The same distance. What was the same distance? 2. Put a 2 for upstream because the same distance. How long did it take? What was my time? It takes 1 hour. So basically, same distance, half an hour, 2. I can circle all the important info. Okay, put in 1 hour for upstream. Your second equation is going to look like this. So now I have a system I need to distribute though. So I'm going to go to the next slide and rewrite all of this because now I have actual space. You need to distribute. Can you guys distribute for me? That 0.5, distribute it to the x and distribute it to the y. That 1, distribute it to the x and distribute it to the y. I either need to make both of my x's, this is a half. I either need to make both of these a 1 or both of these a 1. How do I, well look, which one is easier? My x's or my y's? What's easier to, will be easier to cancel out? The y's, you're right, because the signs are different. So what do I do to 0.5 to make it a 1? What do I do to 50 cents to make it $1? Times by 2, I double it. 50 cents doubled makes $1. So you're going to do that. Multiply your top equation by 2. Don't touch the bottom equation. It's already perfect. I'm going to double this 50 cents. Here we go. 2 times 50 cents. 2 times 0.5. 2 0.5s. 1. And don't forget about the 2 times 2, 4. My second equation I'm going to leave. What questions do you have so far? Are you confused? Is anything like out over your head and you need me to slow down or clarify? Okay. All right, add those two. 1x plus 1x.
2x.
Perfect. 4 plus 2.
6x.
Great. X equals what?
3.
Okay, good. All right, x is 3. How do I find y? Plug in. Which red original equation do you like better? Yeah, for sure pick the bottom. It's like a no-brainer. 1x, 1 times 3, minus 1y equals 2. Three minus 1y equals 2. So minus 3. Negative 1y. Don't forget that there's a negative still in front of the 1y. Equals negative 1. 2 minus 3 is negative 1. Last step, to get y alone, move that negative 1. Divide both sides by negative 1. What is the speed of the boat and what is the speed of the current? Okay, well, when a boat has a motor, does the boat go faster or does the water go faster?
Of course, the water.
You tell me. I'm not going to respond either way. Use your logic. Think for a second. You have an answer of x equals 3 kilometers an hour, or you have the answer of 1 kilometer an hour. You have to figure out what's the speed of the boat and what's the speed of the current. You use common sense and logic to decide. How fast is the current going? How fast is the boat going? Which answer is the 1 and which answer is the 3? You tell me. Hold on, because you've helped. Someone new. Yeah.
X is the boat speed and Y is the current.
You're right, the boat goes faster. The boat travels 3 kilometers an hour, which means my x equals the boat speed. And the current travels 1 kilometer an hour. Okay? Good. It's not just solving the problem, it's making sense of what your answer is. You need to understand what you're doing and you need to make sense of what's happening before you can really finish the answer. On your quiz, your word problem quiz, you better have sentences down there at the bottom. I need to know exactly what your numbers mean. You got a 1. What does 1 mean? 1 person in the boat, 1 boat, 1 kilometer an hour. You need to be clear. You will get marked down if you are not writing your answer in a sentence. Swamp buggy. I took a picture of one. So I went to New Orleans this summer and we did a swamp tour where we saw crocodiles literally swimming in the water. It was really scary because you realize if you just jump in the water, you're dead. So it was very scary because I'm not a fan of crocodiles or alligators and I don't want to be near them or hang out with them or anything. And so you're in a boat and it drives and all of these components are waterproof. So you start going into the marshlands, the wetlands, the swamp, and the boat portion takes over, okay? Most of the time, I'm going to be completely honest with you, most of the time, there's a boat portion where it's like a side that's kind of slick, because this can go in like big puddles, but there's no boat part to hold this one up. But this is what came up for Swamp Buggy. So, they're called like duck boats or something. Yeah.
Wouldn't somebody get like tangled in what's under the swamp? Maybe a log that's deep in the water.
And that's why this wouldn't do well in like a swamp, because you see that there's nothing to give it buoyancy. You know how on the boat you have the sides that give it buoyancy and holds it up? A canoe has it. A rowboat has the arched bottom. You need that. This has no arched bottom. So this might have been a bad example to choose. But, it can go 18 kilometers downstream in 4 hours. Write down the information, circle it, highlight it. 18 kilometers, that's the distance it travels. 4 hours, that's the time. Fill that in your space right now because it's the downstream space. Go to the downstream space. Fill in the time. How long did the swamp buggy go for? It went for 4 hours. How far did the swamp buggy go? It went 18 kilometers. Okay. Sentence number 2. It goes the same distance. What does same distance mean? What do I write for same distance on upstream?
18.
Good. In 6 hours, doesn't it make sense that it takes it longer to go upstream because it's fighting the current? It's going against the current. It's going to take longer. Okay. On our last problem, X was the current, the speed of the current. So let us solve the problem first and then designate that. It's speed of the current, but I just want to prove it to you by the answers. Write it down. Rate times time equals distance. So you're multiplying this box times this box equals 18. And that's your system. That's your equation. So here we go. X plus y times 4 equals 18. X minus y times 6 equals 18. And you need to distribute that. Okay. You could, you know how we talked about how there's substitution and graphing? You could change both of these into y equals mx plus b and graph it if you want to. Do you want to?
No.
Do you want to like try and get the x alone? And then plug it in for the other equation. That's called substitution. Yeah.
Can't we do elimination and multiply each equation by 3, or multiply the one equation by 3 and the other one by 2?
Let's absolutely do elimination. Good point. So you want to multiply the top equation by?
3,
What are you making your y's?
12.
12. You're going to make your y's 12. What do I do to 4 to make it a 12? Multiply by 3. What do I do to 6 to make it a 12? Multiply by 2. And you're going to distribute. Both of them, actually. Ooh, 3 times 18. Just going to do it on the side of your paper because I don't have my 18s memorized. 18 times 3 became 54. Two times 18. That one I know in my brain. I've memorized that before. Okay. All right. Let's cancel out by adding, cancel out the x's or cancel out the y's? Okay, good. Add. 24x equals, I don't know if it goes in evenly. I don't think it goes in evenly, honestly. Bummer. Okay, but we want to know like a speed or the time. So you can't leave it as this fraction. We can just reduce it and then simplify it. That's what we'd have to do. 4 doesn't go into both of them. 6 goes into both of them. Okay, so 90 divided by 6. All the work that you have to do, that's exactly how I do the problem too. So don't think that this is any like more difficult for me. 15 over 4. Okay, now let's actually divide it in. 4 goes into 15. 3 whole times, that's 12. And 3/4. 3 and 3/4. 3.75 kilometers an hour. It's all kilometers per hour. It's not miles per hour. what equation would you like to plug 3.75 into? Which equation is easiest for you? The top or the bottom? Top. 4 times 3.75 plus 4y equals 18. It is very rare that when you do time and traveling that you get like perfect whole numbers, answers, hours. So 3.75 times 4 15 plus 4y equals 18. So on the side of my paper, I did 3.75 times 4 over there. And then I moved my decimal 2 spaces over because 1, 2, 1, 2. So close. Do your last couple steps. Subtract 15 both sides. Divide by 4. Three-fourths.
0.75.
What? 0.75, like that better? Yeah. Okay. On our last problem, X was the boat, Y was the current. So on this one, we got a swamp buggy, and it's going for 4 hours. So this is a long trip. So let's stick with the same situation, okay? Which means that my X, which is my boat, because that's where you're gonna stay with it, this time, the boat travels 3.75 km/h, kilometers an hour, km/h. The current doesn't really travel, current moves 0.75 kilometers an hour. Think about a swamp. Is a swamp like a roaring rapid river? No, a swamp is like barely like moving. Okay. So your job now is to do the exact same problems on the backside. Nothing is harder about it. Nothing is easier about it. It's exactly the same. So go ahead and give it a try. And let's start practicing.